Alrighty, let's get started. Quick game for the second session. Gonna show you some face. I guess you played it already, but I also want to see if you can identify. Gonna show you a couple of faces, and you have to tell me if it's an AI generated or real one. Let's get started. Raise your hand if you think it's AI. Just raise your hand if you think it's AI. 1, 2, 3, 4, 5, 6, 7, 8. Okay, okay. Group dynamics. Second one. Yeah, 1, 2, 3, 4, 5, 6. Okay, 50-50, I would say. 5, 4, 3, 2, 1. Okay, 50-50. Two more. 5, 4, 3, 2, 1. Okay, still 50-50. Amazing. Last one. 5, 4, 3, 2, 1. Just one person. All right. All of them were generated. Sorry. There's a web page here. You know it? It's called This Person Does Not Exist. They are all Stygan 2 AI generated images. So once you reload the web page, it always generates your new faces. Alrighty. But fake news, right? Oh, that's probably not what we want. There we go. Yeah. So on the second part of today's course, I would like to get a bit deeper into machine learning and how to write neural networks. But first things first, we have to clarify some aspects in it. And obviously, right, when we want to program or to code our own machine learning algorithm, it starts with data, obviously, and data is like the new, so to say, oil or whatever. And so therefore we have to talk about data, and we have to talk about data sets. Secondly, we have to talk about training, right? This is like what we know as the training process when you learn a model with certain tasks and it tries to capture certain patterns and whatnot. And then lastly, there is a so-called generalization or optimization process. There we talk about, they're called hyperparameters. So these are like these fine adjustments to fine-tune the model. So to get the output that it fits what we want. And that's like basically somehow the pipeline we will go through each of them. But first of all, I guess we have to talk about data again. So because in data, as it's like the core, the base of every machine learning training and all the models, we will have a look closer into this. So let's imagine we want to build a machine learning model that can classify dogs and cats. And let's imagine we have a product like this door, this animal door, or I would say cat door, which basically says like cats are allowed, but dogs are not allowed. So when a cat stands in front of it, the door will open. When a dog stands in front of it, the door will not open. And this is like a very classical example, like a lot of, if you are in AI machine learning classes, they always start with cats and dogs. And I think it's also good here for our class. So basically here we are facing a very traditional way of machine learning. And there we have two types of machine learnings that can describe as supervised and unsupervised learning. Do you know, have you heard about this ever before? Do you know what it is? Have you heard about it, first of all, supervised, unsupervised? Raise your arm if you heard about it. Two heard about it, okay. So then let's quickly get into this. So supervised machine learning means that we have data that's labeled. So what it means is, here in this example, we have, and also here real world example is, we have a model that's being used to identify if an email is spam or not. And we have data, we have, so to say, emails that are classified as spam. So they have the label spam. And then we have another email that doesn't have the label spam. And therefore we can give that a model and say, like, look, this is the data set of spam, this is the data set of okay, and please try to identify the patterns between the spam and the, let's say, normal emails, and then train your model to use that then for the spam filter. We can, of course, do the same, right, with dogs and cats. So we have images of dogs, we have images of cats, and label them, and therefore we will use here the technique of supervised machine learning. Okay, was that clear? Supervised, what does it mean again? It means that we have labeled data, right? So we have an image, and in the metadata it says, like, this is a dog, this is a cat. Then we have unsupervised machine learning. Unsupervised machine learning means that we have data sets, but they are not labeled at all. So it's just a bunch of images. So here in this example, we could maybe use images of people, animals, buildings. They all come in one folder, right? And then we just give it the model, and then we ask to tell the model, try to find patterns in here. Try to identify if there are groups of objects that belong together. And then the machine learning model can do that for us and can find this kind of hidden structures in it. That's quite handy, I would say, right? Because sometimes we have, like, again, we're talking here also about data sets that have millions, for example, of images. Of course, we cannot go in there, individually and look at them if that's a dog or if that's a person or a building. So therefore, we can use this unsupervised technique to, first of all, cluster the data. And then once they are clustered, then we can give those clusters a name and say, like, oh, look, actually the cluster, the structure, the pattern you found here, these are dogs, or these are people, or these are buildings. And then once we have that, there is an interesting third way of doing so, which is called semi-supervised, which is basically a combination of the two worlds. So that means here in this example, we have images of a certain disease that's labeled. And then we have images of diseases that are unlabeled. And then we say, like, please take a data set, the unlabeled data set, cluster it, and here are my labeled data with the diseases, and then try to figure out what clusters matches with the labeled data sets. So therefore, with this technique, we can use two labeled and unlabeled data sets, and then the algorithm will first of all cluster our data and then label it for us. That's commonly used in medicine, and also, of course, it saves a lot of time when we are looking for hidden structures in data sets that we don't know. That can be used, of course, also in financial districts, or like where it's been used, right? And whatnot. And of course, we will also use that for our example with dogs and cats. But let's imagine we start simple and we just have a data set that has dogs and cats. We see there's written dog and cat, or basically, let's say like this, the file is being named with dog and cat, right? So therefore, we have a supervised data set, and we will go the path of supervised learning. But wait a minute, before we get there, we also have to recap a bit, and actually, how does it come that suddenly we can now do certain things of like supervised and unsupervised learning? Because we have to remember that it's not just the technology or like the GPUs, the graphic cards, that enabled us now to train a machine learning model. It's also relies to the history of where we come from with social media. So we also have to remember that all the data that we use to train models these days come from this history of the Web 2.0, Amazon Mechanical Turk, Google Analytics, social media, smartphones. So basically, we provided all the data in the past 20 years to enable now these technologies as well, right? So we have to keep in mind that all the data we use are actually the stuff that we collected all together. And obviously, when we talk about data, we have to talk about biases. I wonder, like, the terms of bias in data sets, I suppose. Like, what is the first thing? Like, what is the first thing that comes into your mind? Like, when you talk about biases in data, what does it mean? Abstract.
Classification process.
Yeah.
It was classified in a like biased way.
In a biased way, right?
Like the person who classifies as biased.
Yeah, yeah. The thing is that most of the time when we talk about biases, we have one vision of biases, but it turns out that there are multiple biases in the whole machine learning processes. I don't remember all of them. You can also read it by this research paper down there. So I quickly try to recap what we have there. So for example, as you said, we have bias in the data set. So that's for example, we can talk about here historical data sets. So here an example would be that we want to train a model that is specialized in certain job positions, right? But the data set we use is much more, maybe, let's say, male dominated. So therefore, women are much more underrepresented through that historical bias. That means that we will create a model or machine learning that makes decisions much more to prefer males as, for example, whatever CEOs.
I was just wondering, isn't like all this data generally very like Western biased?
There's another part for sure. Yeah, this is the next one that we talk about, the representation bias. Exactly, the representation bias is exactly what you said. Imagine you have like a face detection algorithm classifier, right? And maybe you gonna use, let's say, public available data on the internet. There we know that's much more Western, industrious, and white data that you can get. Therefore, darker skin colors are much more underrepresented. Representants anyway, and so to say, this representation bias is exactly what you mentioned, where we can also have these biases into the data set. Then we have the measurement bias. I have to quickly go through that. So the measurement bias is, I think, comes down to the matter of fact, how do you capture the data? So imagine you have a survey like online written in English, and it asks you certain questions like, I don't know, what's your favorite color, things like this. And the problem is that as it's written in English, it also excludes people who don't speak English. So suddenly your data set just represents the people who are native English speaker or understands English. So we also have to think about how do we measure the data set, and how do we create a data set, and what is the interface to present this. Then we have the learning bias. The learning bias is a bit, I can just give it an example. So let's say like this, that you have a bank, they want to create an AI that identifies if a person gets a credit or not based on a certain area where they live by their zip code. And suddenly, just to the matter of fact that you live in that area, I don't know, let's say where statistics showed that there are people with lower income, you will fall into this category, and then you are not part of it to get a credit by a bank, for example, just by your zip code. That would be, so to say, the learning bias. Then we have the evaluation bias. So my understanding here is a bit like this, and that comes also down to the nature of how machine learning works, is that we always have a training data set on the one hand. On the other hand, we have a so-called evaluation data set. And once we train a model, we always take the separate evaluation data set to show it against the model to say, like, this is the source of truth. And once the model is trained, always identify if that matches with the separate data set. That means that if the separate data set has a bias in itself, it can also threaten, also to say, harm the model itself. We go into this, maybe a bit difficult, the evaluation bias set. Then we have the aggregation data set. So that means that, imagine we have a model, we train the model, and let's say we train a model for certain medical purposes, forgetting that, as we know, right, for example, that we cannot use the same medical laws between men and women, but we pretend that this model can be used for all people at once. So therefore, we also see here that we have to maybe create two different models compared between the genders, for example. So that would be a different, that would be the so-called aggregation data set. And then the last one is the deployment data set, and that is also related to the interface itself, like how do you present the result of the model? Because like we have the measurement data set, and that's how we generated the data. So that means that that was the way how data went into that model. And actually, we also have to present the same way that the data to the interface back again to the people or to the users. But if the data, if the interface, the output interface is different, again, let's say you have a different language or something like this that presents the result, suddenly you also exclude people to be part of the result of this model. So to wrap up, there are different kinds of biases when we talk about machine learning. And very quickly, I would like to show you some of the famous data sets that are being used around the globe, which are very important because in the whole AI world, there's always this challenge where they say like, okay, I have an image classifier. And then scientists say like, but have you run it against this data set, for example, here ImageNet, and can it really identify the objects in this data set because we know this is the golden standard and this is the data set that seems to be the cleanest, so to say. And one of the biggest one here with images is the so-called ImageNet. It exists of, I think, 40 million images. It's public source, you can download it. And here the critics is, coming back to your aspect, is that this is also much more North American, Western Europe data set. So obviously here we can also see that there's a bias in it. And of course, right, like those research groups, they always try to get rid of their biases, and there's always this kind of ping pong effect of feedback loops. Another famous data set, which is being used since obviously quite a while, is this MNIST. Basically, this data set exists of handwritten digits. So in practice, this is being used like if you write a letter, like an analog letter, put it into the post box and send it. Obviously, there's nobody that reads the numbers of the letters anymore, right? There's a machine that looks at the address, at the numbers, and then it's automatically distributed to the right place where you want to send it. And this MNIST data set is kind of a golden standard to identify digits. Same here, we have another one that's kind of a very small data set, 60,000 images, 23 by 24 colored image with 10 classes. It's called STIFA. It was for years also kind of benchmark data set against object detection algorithms. The same we have for fashion, obviously. We can also do things like that. But we also have data sets like this with faces and people on it without their consensus. Here mainly this is the COCO dataset, which is also in a lot of object detection, especially human detection algorithms, the golden standard to work against or with it. All these images, they come from Flickr. So here I would like to point out that, and it's the same for Instagram, obviously, right? We upload stuff there and it's gone. We have no control, right? We agree on it that they can sell these data sets for different companies and so on and so forth. So this is an important keynote here is that, Flickr has been used for different products to train with the data set. That's another one. This is Adiens, I think it's called. Here, the main purpose was to create a data set between, what was it again? Was it gender or age? Can't remember. I think it was age and gender estimator, exactly. So they also used Flickr as a source, and then they separated it into gender and age and wanted to train a model that can predict these categories. That's like a web page I'm going to give you away where you can find all of these different data sets, especially when it comes to human and face detections. And it has like a critical point of view, tells a bit also how these data sets had been used by certain companies, by also law enforcement and so on and so forth. And this one here is maybe interesting because sometimes these data sets are also being used in the sense that they are not meant to be. So this is the NIST data set. These are, I think it's called mugshots. So Fahndungsfoto in German by the US police, right, where you have like the person from the front and from the side. And the main purpose of this data set was to identify mugshots, basically. So that's why they created this data set. They just wanted to see like, okay, is this photo what you give me a mugshot, yes or no? But it turned out that suddenly other people used it and trained a model on to identify if a person is criminal or not by the face, which is of course obviously right critical. And so the point I would like to make here is that you have these data sets, you collect them for a certain purpose, but you never know what they are used later on. And German history also told us that we also never know how these lists and data can be used later on. And then there's another interesting data set. I would like to go a bit more into detail because that influences, I think, you all in your everyday, like when you use AI, especially generative AI, which is called Lion. And Lion is not a data set as I describe it as images. It's actually, so far, I think the biggest data set of images around the globe. It's called, this one is Lion, and they have different subcategories. I think the biggest one right now is Lion 5B. So it exists of 5 billion images. But what they do is they don't save the data sets. What they do is they have, so to say, a list of URLs where you can find the images. And researchers, I think from Stanford University, they also found child and sexual abuse material in that data set where the Lion company, they I think from Hamburg, as I remember, had to clean and had to basically cut the access to this data set for a certain time to overfilter, so to say. And they are always, facing certain issues with it because the problem with their data set is that, again, they are not storing the data. They are just storing the links, the URLs to those images from web crawlers. So this is like a circle, what you can see here. So they have, so to say, a web crawler. It's like an application that they wrote to basically throw it out into the internet, and they scan all your web pages, everything out there. And basically what they do is they store the source code of the image into an archive, into their web archive. Once they have it, again, like we're just talking about text, then they analyze if in the source code is an image implemented, something that ends with PNG, JPEG, whatnot. And once it is like this, then they basically extract this image and run it through their Lion algorithm, which then analyzes what is on the image, or basically just takes the image and also looks at if there is like a alt text or like a meta text underneath that describes what is in the image. Because what they are, let's say, good at it, or let's say good in a sense, or what they have as a bonus is they are not just delivering the image, they are also delivering the description of the image. And maybe now you get an idea of how that can be used. But to conclude, they also now, once they have the image and the description, they run it through a clip filter. Clip is also interesting here. And then they create a Lion data set. And therefore, it brings us to a first interesting intervention here, because as we know that this huge data set just consists of URLs, and they never store the images, they literally just store the text. It means that we can interfere here because certain URLs can change over time, right? So sometimes the domains does not exist, but it still exists in their data set, right? Because they crawl the internet, I don't know, every 5 years or something. And so all domains still exist. So what I could do theoretically is I could have a look at the Lion data set, go through the URLs and identify which URLs do not exist anymore, and then could register my own web page under the exact URL what they have in their data set, and then place instead, they think it's a cat image, and then I could maybe place a dog image in there. And suddenly I could manipulate the data set. They think it's still a cat, but in fact it's a dog image. So again, right, smart technique, but on the other hand, also they can there is an interesting way to hack this data set. Because when I want to use the data set, what I do is basically I just download the Lion data set with all the URLs, and then I have to download the images by myself, right? So again, they are just providing me with a list of URLs and the description. And then the same, maybe as another example here, is Wikipedia, as I mentioned last time. So Wikipedia, they don't want that you are crawling the Wikipedia, like that you don't use some application that extracts the data. What they offer is they tell you, like, look, we have a bundled zip file here, which we gather together every year for you. And when you want to get our data from Wikipedia, this is the date and the time where we publish this, and then you can download. Once I know that, I could basically change certain articles maybe a couple of hours before this date where they publish a data set. So therefore, I could also obfuscate these data, which will then be used, for example, for large language models to train. So researchers have shown that this technique works, because with Wikipedia, it's like this, right? You can change articles, and then you have the moderators, and then they can return to the original state if they think that what you wrote there is wrong. But basically, for some articles, first of all, your change goes into the official Wikipedia before the moderator returns it back. So there's also another interesting aspect here of changing in real time when knowing when they publish the thing. But let's go back to Lion. I guess image and text, right? We know it. So obviously this data set is being used for Midjourney, DALL-E, and Stable Diffusion, because these models are exactly what we're supposed to do with it, right? We can type in a text, and then they generate the image for us. There's this interesting game here. I think we don't have the time to play, but I can quickly show it to you. It's like an AI bingo. No, doesn't work. Wrong. Okay. Well, oh, did I? Oh, sorry. Oh yeah. Yes, there we go. Oh, it's blocked by the university. Interesting. Yeah, but I think it's not worth it to play now. So basically, you can play it by yourself. It's called AI Bingo, where you will see 3 different AI-generated images, like the one here from above. And then you will be asked which of them is generated with Midjourney, DALL-E, and Stable Diffusion. So it also is a bit like a quality check of, can you identify the Gen AI that generated these images? But again, back to the text to image generator. So we have a text. it runs through a thing that's called clip, whatever that is. It goes into the model and then it generates this image for us. So the question, because it comes up the second time, what is clip? So clip is a model that's been created by OpenAI, and it has a huge influence on a lot of tools. So here in this graph you can see, so the headline here is like high-level architecture showing the state-of-art machine learning models. And we can see on the top, there is Lion 5B, which is the data set. Then this data set goes into clip from OpenAI, and then we can see underneath the structure, then this goes into Midjourney, Stable Diffusion, DALL-E and whatnot. So it seems to be that first of all, Lion is the source of a lot of applications that we use. First, and secondly, it goes through a filter that's called clip that does something with it. But what does it do? I don't know. Let's explain. Let's see. So clip is actually the magic that we can use to try to find similarities between text and images. So this clip model, as we have seen, is being trained by Lion. And as we know, right, Lion is always image and text. So clip can make an understanding out when you say like, I don't know, like a cat on the street, then it can identify, all right, this image is a cat on the street. And what's interesting about clip is that usually when we talk about the supervised machine learning with, identify images of cats and dogs, it just understands a cat face and a dog face, or like what is a cat and what is a dog. What clips understands is also it understands the context, so it also understands the background, for example. It understands like, in what context, for example, is this animal or this subject, so to say. And this enables a lot of potentials where you can literally do text prompting and generate images. And as a side effect, you can also ask clip things like this. So, for example, you could ask clip things like how much percentage of certain characteristics, I don't know, words, adjectives, whatever you ask for are in there. So here, right, we see, for example, on the top right, there's an astronaut, and then you can ask like, how much percentage do you see a woman in there? How much, and so on and so forth, right? And it will give you back the percentage of it. And the interesting part is here that you can ask them anything. And because right now here, we kind of left the space of what makes sense for us as humans or not. Actually, we are now basically working here or talking here about the so-called vector space, the, let's say, measurement or the numbered part of understanding of the visual images, so to say. I give you a quick example here, and now we can go to a quick tutorial. So please open your notebooks now and go to this web page. I hope they're not blocking the... didn't try. Amazing. That's good. Okay, so please go to nullisland.tel. There you should find this web page. Does it work? No? Wait, but for me it's working. Really? Don't you have VPN? Or maybe you can use your smartphone? I don't know. Okay, because it's not HTTPS. No, it is actually. Damn it. Can you all get around this? Yeah? Do you know how somebody is stuck here? No? Nullisland.tel. Yeah, somebody can open a hotspot quickly. But actually, well, maybe the only part is like we just have to get there, and then from there we go to a Google Colab, and then maybe there you can use the normal internet again, because we will use a bit of data. So I don't want to warn you, if everybody connects to your hotspot, then you will run out of data.
I think you can use the boost Wi-Fi.
Yeah, and actually I got kicked out of guest. No.
There's like ik heb online gewandt, this is network called AKDK from the Management, and the password is DK Classic.
Yeah, I also got kicked out of the internet here, interestingly. Let's see. Open browser. Yeah. There's a timeout, I assume, right? If you're not using. Okay. Let's see. All right, back again. Okay, everybody arrives here. So then let's go to this first part here, which is called feature representation. And here on the button, launch feature representation, we will open Google Colab notebook. All good? All right. Everybody arrived here? Yeah? Somehow? Not yet? Again, right, like you go to nullisland.tel, and then it's like the first button here on the top, feature representation. And this, actually now, I think you can now go back to the public Wi-Fi. I hope they open this one. All right, but here, this is Google Colab. I guess nobody, or not so many of you have used it. So I give you quickly example. So the nice part here about this tool, even though it's from Google, is that they offer us free access to strong GPUs, graphic cards, which we can use for coding and training neural networks, which is quite cool. It's for free. Obviously, you also need a Google account. If you don't have one, I hope you have one, I guess. Otherwise, it just set up a fake account. Then you can use this Google Colab. And so Google Colab again gives us access to GPUs, to graphic cards, and provides us with their data center power. And here in Google Colabs, we can define code, I would say, that we can execute. This example is the zero-shot image classifier. Quick reintroduction on the top. It's basically you give them an image, and then you ask for certain categories, and then it spits out, I think the 5 topmost categories it sees in the image. And how can we run it now? So basically, when you scroll down here on the image classifier and of this notebook, on the left side here, when you hover over these blocks, there is this play button on the top left. We don't have this one on the first block because this is not code, this is more like a description, right? But here, when the code starts to appear in the second block, we see there is this play button. And what's pretty nice about this Colab thing is that now we can run the code step by step, block by block. So that means, we can have a look at the first block, trying to understand what's going on there, run it. Then we go to the second block, try to understand what's going on, and then run it. Of course, you can also run the whole notebook or this Colab thing at once, which I think it's here run all at once. But I think for the moment, we just run them one by one, and then we will identify what's going on there. So for this example, I will not go deeply into the code because here it's more like about playing around a bit with the stuff. So first of all, I think let's give them a shot and let's run the first block here under install required packages. So I click on the play button. That takes a bit of time. So what this block does is basically it installs some libraries in the background. And if the internet is hopefully fast enough, then it should take so much time here. So we see right there's a cursor blinking, and what it does now is that Google Colab creates a virtual machine for you on their Google server where it executes the code now.
There is a warning. This notebook was not authorized
Yeah.
by Google. This
Exactly. Exactly. Yeah. So, for example, there could be some hidden code that, I don't know, opens your webcam, does a photo, and sends it to my server. Things like this, but not this code book. All right. So on my end, this got executed. It took like 33 seconds, and I see here on the left there is the green check to say like, okay, you are good to go to move on with the next block. Everybody did that, right? Cool. Then let's go on, and then let's get to the next block here. So I'm gonna execute this one. And now what we do is we download already trained model. That takes a bit of data. Let's see. And it should also show you some status bar down below there. And no, it's still operating. All right, so on my end, this got successfully executed. And then you should, on your end, it also should look like that. The reason why you see, basically when you scroll down, right, you see that already. You might think of, hey, right, already got executed, but basically this notebook holds the state for my last session. So it's quite handy sometimes to see what you have done last time. So, but it's basically not running. So you always have to execute block by block. Okay, but once you get the green bars here, that means like, and also again, right here on the left, the green check, we can go on for the next one. Here we just do it, just execute it. These are some helper functions that will help us with scaling the images, defining a couple of grids and texts. That should be quite quick, doesn't take so long. And here now we can go into the first example in this block. So basically what you will do now here, and let's just run it and we will see. So I execute this one. And when I scroll down, I see here the result. And I see here that I uploaded a doc image. So this is this URL here, right? So basically we just take it from the internet. Can quickly go there. That's the image. And then I ask the model, or I gave the model these categories here. And then I asked the model, what are the most representative categories in that image? And here, obviously, the model told me, yeah, I see almost 100% that this is a dog and not a cat, a horse, or whatnot, right? So I would say that the model did exactly what's supposed to do, and it correctly identified that this is a dog. You have that, right? Yeah. Okay, so then let's go on to the next one and execute this one. And what we get here, another nice image, and it identifies this correctly as a schnitzel. However, we can also ask for unusual categories, and we can also ask them basically things that are not representative, but for the machine it is actually representative. So let's upload this one here. This, I think, is an image of myself, and here I have some categories like smoked salmon, schnitzel, pizza, teacher, hot pot, millionaire, nurse, hacker, whatnot. So it seems to be that I'm more like a tech oligarch for the model than a teacher, unfortunately. And what's interesting here is for me that to play around, to understand actually what the model sees, right? Of course, we can now try to make some sense of like, why does it see more like a tech oligarch in that image than a teacher, for example, or anything else like a hacker? Or maybe I could also, I can easily, of course, right? Let's say, I don't know, instead of pizza, I'm gonna just type in here man, I don't know, or let's say I can also execute this. Let's see if we can change it. So I'm still more a tech oligarch than a man. I don't know. Can I maybe I'm more person than a tech oligarch? I don't know. So let's run it. And still I'm more tech oligarch than a person, unfortunately. So it seems to be something for the model tells them super strongly there's definitely a tech oligarch here. And when I ask you, for example, these two images here, when I ask you, and we can of course also ask anything, right? Who of them are more happier to you? Or what do you think, which of these person is more happier to the AI? What would you say? Would you say that she is more happier to the AI, or would you say that the person on the right is more happier to the AI? On the left? Well, let's find out, right? Let's see. So she is pretty happy to the AI, I would say, right? Almost, let's say 2.998 or something. And here again, right, I just asked for two categories basically, right? Happy and angry. Could also ask for sad or something. Happy and sad. Let's try the other image. So it seems to be that even though she looks slightly a bit more angry than this person. So I would say this person is probably more happier in the eyes of the AI. And how about these two guys here? What do you think? Who is more happy? The right? Schnitzel is more happy? Let's try it out. It's a bit more angry. Oh, it's actually okay. Well, I didn't took the original image, unfortunately. Let's see. Well, you can decide. I don't know. Probably the Schnitzel is a bit more happier, right? And yeah, right. So you can basically, I would say, it somehow makes sense. It somehow doesn't. And you can literally ask them anything, right? You can upload any image here and ask for any category, and then ask the AI certain topics. You can also ask for, I don't know, what do I have here? I think there's a robot, as I remember. And to the AI, this looks much more crazier than sexy, than clown, than animal, than gangster, right? And once we know that and we get an understanding of what the AI sees and how it identifies certain characteristics, obviously we can also play around with, right? And we can kind of manipulate or shape the image to drive them into certain categories. And that's what I would like to emphasize to you in the next step, or maybe also here quickly, because that's quite fun. I quickly go up there into to my image, and you can also, for example, ask things like totally nonsense categories, like words they don't exist, but still the AI tries to identify certain categories or percentage out of it. So here I just use some fantasy words, and it looks like that I'm more like giggle muggly than whatever, right? Or you can also ask for Pokemons, right? So if I go in here and I have another prepared label that comes with different Pokemons, the Pokemon descriptions. Like if you read this, I'm not sure. Actually, I'm also not the expert in Pokemon. I also have to look it up. But when these are different Pokemons, and I ask it, and it looks like that I am much more this Pokemon. I don't know. Let's have a look how this Pokemon looks like. Makes sense, right? I mean, color-wise, it makes sense, I would say. Yeah. I don't know what the other ones look like, so bit too old for this, but yeah. Right. And of course, you can also ask for ethnicity. You can ask for, I don't know, for animals, like how much dog is in it, how much cat is in it, right? I wonder what was that again. I prepared something here. We could also quickly play around with it. This guy. Let's see. Maybe let's replace my image with Alex Karp's image. And let's see what Pokemon he is close to. Mewtwo. Well, I don't know. But anyway, the main thing is here that, you know, it looks like these two guys are, they have basically this kind of interesting categories. And sometimes, you know, also people tends to have different ethnicity as they would like to, right? For the AI, which is quite interesting. And so, and how is that being used, or why should you know, why do we get, like, how can we use it in a, or like, how do companies, for example, use it in a practical sense? I mean, it's like nice to play around. One use case scenario is this NSFW, which means not safe for work filter. So basically what they ask as well is, you could, for example, also ask for categories like how sexual is the image, how naked is the image, how porn is the image. And when this index goes up, it means that maybe this image is not allowed to, once you generate it with Gen AI, it's maybe not allowed to present to the user. So this feature representations, which we played around with, are being used for this NFSW, not safe for work filters, for example. So that would be, coming back to our topic, maybe one of the police officers that we have in place here, right? So we could use that and say, like, if one of these categories raises up, then maybe this image is not safe to present to the on the interface to the user. And again, we have here the chart again, right, of how that's been used. We have the clip model, so it seems to be that everything runs through that, which gets filtered, and then it goes through into our applications. And then there's another interesting sub data set in LionB, which is this aesthetic predictor. So I'm gonna quickly, because we're running slowly out of time, quickly go through that. So it turned out that Lion, they also trained a model that has a subset of data that predicts aesthetics. So here you can see a couple of images in the background, and which are part of it. And these aesthetic predictions, obviously, they need to come from users, from platforms, right? Where people decided to, okay, this is an aesthetic image and this is not. And there is this web page, or like this batch file here. It's called Simulacra Aesthetic Captions, and that's been used for Stable Diffusion and Glide and so on. And a community on Discord, for example, voted on certain images if they are aesthetic or not. And they had like a rating from 0 to 1, from 1 to 10, like how aesthetic this looks like. And here we see, for example, one of the very aesthetic images that are in that, where the community voted for that these are very aesthetic. And then they turned out, by researchers found out that, and here we have again the bias, that the group or the community who voted for this aesthetic images are mostly Western, educated, industrialized, rich, and democratic people. So here we see that also that where the base of the data set comes from this group of people. And there's another web page, which is this one. It's called dbchallenge.com. which is another community that voted for aesthetic images. And I don't know, I guess it's like a nerd webpage for photographers, but they had also very huge influence on a data set as well. And it turned out like here you see the top users of this webpage, and you can also get a glimpse of, right, like who influenced the data set, what clip thinks of that this is an aesthetical image. Why I'm gonna tell this is when you, for example, type into your common AI, please create me a very looking nice aesthetic image, it's based on the subset of Lion aesthetic thing, this one. You can also download this one, by the way. So they also provide this. There's a version 1 and a version 2. And also, I think I have a demo web page here where you can also get some, subsets of what's defined in there in this data set. And when we go back into our nullisland.tel, we can quickly open the second example. Oh. So nullisland, and then we go to aesthetic predictor. And here we do the same thing as we did for the other example, right? We execute just the blocks one by one. So we start with the, okay, so I got this one. Maybe you got, okay, no, it's me. That's fine. Okay. Might be, I'm not sure. Maybe you get a warning that says like you have too many sessions at some point. Then it will open a window and then you have to click the already open session because it's like obviously a free version. So they will just allow you to run one notebook.
Was it also your email address?
Yeah, that's another account, another fake account. Yeah. And then let's run the first block. I run the second block. Here we, again, the first block just installs some libraries that can do the magic. The second block, I think already runs some aesthetic predictor exactly. So here in this example, I think I give the model 2 images of 2 pizzas and I ask for which image is more aesthetic to the AI. And what I think here is maybe interesting for you, whatever, for example, if you run a business or something, right? Let's say you have a restaurant. I think it's maybe also good to run it through a model like this to identify if your image also looks visually appealing to the AI or not, because then the chances of obviously also higher that you get crawled by the AI basically. So that's what businesses do, so to say, they not just make nice photos, obviously, right? They also run it against certain AIs to identify if they match a certain score to being catched by AI systems to land on the higher ranking on Google.
So you want to say that if the image is aesthetically appealing to me, to my human eye, it doesn't automatically means Jesus Christ.
Yeah. And there are also applications where, like tutorials basically, like how you can make the image visually appealing to the AI, right? So for example, this on the left, like in the tutorials, for example, they also tell you like, okay, you have to pump up certain colors to visually match or like to appeal more the AI, things like this, right? I mean, here it's, I don't know, of course, right? To us as humans, very subjective, but to the AI, again, when you want to play around with, that might be a tool that you can use, right? And right here, you can like these are the 2 images. Just if you want to play around with, these are the 2 images that are defined in the code. It can be anything. You can also upload 3 or 4 or whatever, and then it just gives you back the score. And then let's quickly, before we go over here, is the last one I would like to talk, and that's Lion Art, and that's for us as artists very important, because in Lion, there's also another subset that defines how art looks like, which is even crazier, because here we have literally a data set that's also been trained on these different images, and here you can get a glimpse of what OpenAI, for example, understands as art. Here on this link, you can go in there and you can have an idea of somewhere here. I don't know. Take a tour, I would say, right? Somewhere, I can't remember. Probably it's somewhere here in the subset. Just saying, there's also a definition of art. And last but not least, I know you want to go. I would like to show you a quick hack how we can change the categories very easily. So let's imagine we have the same example that we had there, right? We upload the apple, we give them a couple of categories. I don't know, Grammy Smith seems to be like a category of apple. Huh? Right, yeah. And so it detects that it's correct. It turns out when I write something in front of it, suddenly I can change the category. So why not quickly do that? So last example for today. Let's go back to our Null Island web page here, and we open the last code lab. And let's execute that. So again, installing a couple of libraries. Takes a while. Actually, I know you want to go. Let me quickly go because, right, we see that's already obviously executed here. So what you know, same thing as usual, right? We upload the image, we ask certain categories here like angry, happy, funny, sad, surprised, neutral, and it identifies that as sad. Seems to be it's working. Let's imagine I upload an image of myself, and I just print the word dog on the top left and the bottom left. The result. Actually, didn't get executed yet, so I have to run it, unfortunately. Sorry for this. Then let's do it quickly. That's downloading, I guess, right? Internet. Okay, for the ones who want to go, obviously you can also do it by yourself, right? Next homework for the day, because there is a huge gap now between now and the next session because of Easter holidays. This is a homework I would like to emphasize you to play around with. There are these two web pages, PimEye, I showed you already. On the left side, there is this web page which is a bit safer. Like I think there you can upload your stuff, like an image of yourself if you like to, but you can also obviously also take another image, right? Remember, like this person that does not exist, you can also just generate one from there. And this one, basically, when you take a photo of yourself and uploads, it tries to identify how much money you earn. And so, yeah, I don't know. It will work. Probably I just didn't select the right one. Did I? Open? Or maybe it's running. Or maybe I have to drag and drop it. Try it out by yourself. So the homework is here, first of all, upload an image, see what's the result. Second one is then manipulate the image in a certain way that you can modify the output. Like try to think about like what can be done to shift, so to say, or reverse the output what usually they, I would say. And then the last part is kind of summarize your findings and what you have found out. For example, here, how much do I have to cover my face that I'm not getting detected anymore? Probably this web page would say try to work with some celebrities, people, from a public life, upload the image, and then maybe you Photoshop or something you can, or whatever AI generated stuff you can then use it. So yeah, that's basically it for today. That's the next course. We will then meet on the 21st of April for the next session. And let me quickly finish this one because this seems to be now done. So, and we are quick. So this again, run that one. Because this gives you already a glimpse for the homework. So this one we discussed already. I'm gonna take this one, upload the image of myself, run it against these categories. Here the main goal is I would like to turn my image into a dog, so to say, like in the category. Here it seems to be it's still a man, right? So the attack is not strong enough, even though it's quite big there. But how about if I make it a bit bigger, the image here on the left? Let's see. Well, now it turned the style. Obviously, this attack is very obvious, right? You see it, it's obviously written dog there, so that doesn't make sense, I think, in real life. But how about if we print a t-shirt where dog is written on it? Let's see. Unfortunately, the attack is not strong enough. I'm still a man compared to a dog. But maybe we can also make the attack a bit stronger when I print a dog on the back of my laptop. I don't know, let's see. All right, there we go. Seems to be now we attacked it and fought the network to predict that there's much more a dog than a man in this image. This just gives you a glimpse of the homework, like, with what you can play around with.